Hello viewers, today we are going to see about Bohr model of the hydrogen atom. First point, the model of the atom proposed by Rutherford assumes that the atom consisting of a central nucleus and revolving electron is stable, much like Sun-planet system. So according to Rutherford's model, we have Sun at the center and the planets are revolving around the Sun, and all the planets executes a stable motion around the Sun. Similarly, for an atom, it contains nucleus, the electrons are revolving and the electrons are stable. But we have to remember the difference between the planetary motion and the electron motion. For that, the planetary system is held by gravitational force. So planetary, all the planets revolve around the Sun and they are stable, and the force executed between the Sun and the planets is gravitational force. Whereas in nucleus electron system, in the atom, being charged particle, that means we know that electrons are negatively charged particle, and inside the nucleus we have protons and neutrons. Protons are positively charged particle, positive charge. Therefore, there will be a force of attraction. So, Coulomb's law comes into picture. So, the nucleus electron system being charged objects interacts by Coulomb's law of force. So, you know the Coulomb's law of force, F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by distance square, say R square. Charge of the particles, product of charges, and inversely proportional to the distance square. It can be attractive or repulsive, that depends upon the polarity of the charges. So the nucleus electron system being charged objects interacts by Coulomb's law of force. So we cannot blindly follow gravitational force assumption as made by Rutherford model. Okay. We know that an object which moves in a circle is being constantly accelerated. So, an object moving in a circular path is constantly accelerated. So the acceleration being centripetal in nature. So this is centripetal force, centripetal in nature. So an object moving in a circular path, so assume anti-clockwise, this is an object moving in a circular path is constantly accelerated and we can see there is a centripetal acceleration. So this will have a centripetal acceleration that is moving towards the center of the circle. According to classical electromagnetic theory, an accelerating charged particle emits radiation in the form of electromagnetic waves. So when a charged particle moves in a circular path and it executes acceleration, then the particle emits radiation. So this particle will emit radiation. Emits radiation in the form of electromagnetic waves. So this radiation is electromagnetic waves, EM waves or radio frequency waves. So an object moving in a circular path is constantly accelerated and it has centripetal acceleration. So also when a particle is moving in a circular path, because of the acceleration, it radiates energy and it is in the form of electromagnetic waves or RF waves. The energy of an accelerating electron should therefore continuously decrease. The energy of an accelerating electron should therefore continuously decrease. So this electron, assume this is electron moving in a circular path, is continuously accelerated. Therefore what happens is it is giving off energy based on the statement. An object moving in a circular path is constantly accelerated, and this is because we have centripetal acceleration. So because of the acceleration, there is a radiation of energy in the form of electromagnetic waves or radio frequency waves. So if you consider this to be an electron, some energy is radiated. So there is a loss in energy because of centripetal acceleration. So therefore, an accelerating electron should therefore continuously decrease because some energy is given, so there is a loss in energy. Okay, so the energy of an accelerating electron should therefore continuously decrease. So the energy decreases because of this electromagnetic radiation, because some energy is given off as electromagnetic waves. The energy of an accelerating electron should therefore continuously decrease. The electron would spiral inward and eventually fall into the nucleus. So because there is a continuous loss in energy, so that it goes into a spiral path and finally moves into the nucleus. Because the electron is negative and the nucleus is positive, and there is a loss of energy because of radiation, so it has to go and settle down at nucleus, which is positive charge. So this can be said pictorially as, assume this is the electron, E minus electron. So slowly there is a decrease in energy and finally it gets into the nucleus. So this is nucleus, proton. So we are considering hydrogen nucleus. Thus, such an atom cannot be stable. So, in this case, we cannot say it is stable. Stable means nucleus, electrons should revolve around the nucleus and there should not be any loss in energy. Only if there is no loss in energy, then it can have a stable movement of the electron around the nucleus. Since there is a loss in energy, why this loss in energy is happening? Because an accelerated charged particle will radiate electromagnetic waves or RF waves. Therefore, there is a loss in energy. Therefore, the electron loses energy and finally gets settled down in the nucleus or proton. Further, according to the classical electromagnetic theory, the frequency of the electromagnetic waves emitted by the revolving electrons is equal to the frequency of revolution. So, the frequency of revolution is equal to the frequency of the electromagnetic waves that is radiated. So, the electromagnetic waves has a definite frequency f, and it is this frequency and the rotational frequency along the nucleus should be equal. As the electrons spiral inwards, their angular velocities and hence their frequencies would change continuously, and so will the frequency of the light emitted. Now what happens is, since there is a loss in energy, it gets spiraled up. Therefore, acceleration decreases. The distance between the proton and the electron decreases slowly. Therefore, there is a variation in acceleration, distance, and continuously there is a loss in energy. It is not stable. Therefore, there must be some spectrum continuously. We cannot have the same wavelength. The wavelength will keep on changing. Thus, they would emit a continuous spectrum. If it is going to be stable, then we can say, okay, it is stable. But since there is a loss in energy, it is not stable. Therefore, it has to emit different frequencies, but it is a continuous spectrum. It is not a discrete spectrum. In contradiction to the line spectrum actually observed. So, whereas in Rutherford, what is told is, he observed only particular wavelengths. So, nothing has been told in between what is going to happen, but Bohr's method of analysis gives a clear picture why there should be a continuous range of frequencies because of this condition. Clearly, Rutherford model tells only a part of the story, implying that the classical ideas are not sufficient to explain the atomic structure. So, this is the basic idea of the theory proposed by Niels Bohr. So, the basic idea is, when a charged particle moving around a circular path gets accelerated, we call it a centripetal acceleration. When there is a acceleration, there is a radiation in energy. we get electromagnetic waves. Electromagnetic waves are radiated. Since some portion of the energy is being radiated, the electron loses some energy. So therefore, everything gets altered. The distance, the centripetal acceleration, everything is modified now, and it is continuously modified, and the electron takes a spiral path and finally it gets into the nucleus, which is positive charge. So there should be a continuous spectrum, because continuously the acceleration of the particle keeps on changing because of the energy radiated from the particle in the form of electromagnetic waves. Therefore, there should exist a continuous spectrum. This is the theory proposed by Niels Bohr based on the investigations of Rutherford. Rutherford told in a particular, we can see only particular lines of spectrum, but he does not able to prove whether the spectrum would be continuous or not. But Niels Bohr has demonstrated this concept, which helps us to redefine the atomic theory and the radiation from the charged particle. So that's all about this video. Thanks for watching. Nandri.